Let's continue solving systems of equations by substitution. The warm-up here, it says draw an example of a system that has one solution, no solutions, or infinitely many solutions. So remember, if we've got one solution, and I'm going to go ahead and draw an xy plane on each one of these. If we've got one solution, that means the lines are going to cross in exactly one point. Right there is where they cross. They get one solution right there. No solutions would be something like this. We've got two lines that are perfectly parallel. They never cross. So these continue going out in each direction and they never intersect each other. Even if it was off the screen, that's okay on one solution. But on this is forever in both directions and they never intersect no matter how far we go, up, down, right, left, or anything like that. And then if we have infinitely many solutions, that would be something like this. We've got a line and then we've got another line that happens to be right on top of it. Okay, pretend that's right on top there. That's one solution, no solutions, infinitely many, they're right on top of each other. All right, so far the systems that we've solved, each one of them has had one of the variables that's already been isolated, it's already been solved for. Well, that was step number one. Well, what if that's not done for us? If it's not done for us, then we have to pick one of the equations and one of the variables to isolate one of those variables. So let's take a look here. We've got the 7x minus y equals -9, and we've got x plus y equals -7. Now let me tell you which one would be the worst choice on here. The worst choice would be this one right here, and let me show you why. If we have a coefficient in front, here's what we're going to end up doing in order to solve for that. First of all, we'd have to move the y to the other side. So this would be 7x. The y would become positive, and then I'd have a -9. And then I'd have to divide everything by 7. So that's good for the x term, but take a look. We'd have a 1/7 as a coefficient here. We'd have a 9/7 as a constant right here. So that really makes a mess. So if you can find one that doesn't have a coefficient or a coefficient of 1, or at the very least one where they all would go into each other, like if this were a 14 and this were a 21 or something like that, that might work out okay. But the 7x, that would be the worst one, okay? So the negative in front of the y, that makes things a little bit more difficult. But if you take a look at the two of these, either one of these would be totally okay. So the one that I'm going to do is I'm just going to do the x. So here's what we're going to do on this one to isolate it. So I'm just going to subtract y from both sides, and we get x equals, this would be -y minus 7. Now I'm going to put a dotted circle around that because this step right here is going to get used again a couple of different times. So take a look right here. Now if I took this second equation and I solved for that one, in fact I'm going to label this equation number 1 and equation number 2. So what I've done here is I've made another copy of equation number 2. If I've used equation number 2, I can't plug it back into equation number 2. That would be like going around in a circle. So what I'm going to do is I'm going to take this and I'm going to plug it into equation number 1. So wherever there's an x, here's like the dollar, I'm going to put -y minus 7. That's like the 4/4. So I'm going to take this and I'm going to put it right there. So here's what we've got. We've got 7, and I'm going to put this in parentheses, times x minus the y equals -9. So I've saved a place for it. I'm going to plug this in parentheses. Again, really good habit. So wherever there's an x, wherever this equation was asking for an x, we're not going to give it an x. We're going to give it -y minus 7. So -y minus 7. Now, again, we've got a more complicated equation here than either one of these, but at least it has one variable and we can solve that. So let's go ahead and distribute. So this is -7y. This is -49. This would be -y, and over here we have a -9. So let's see here. If we put the two of these together, let's see, we have -8y minus 49 equals -9. We're going to add the 49 to both sides, so we get -8y, and then over on this side, -9 plus 49 would be 40. And look at this. This is looking pretty good because 8 will go in there evenly, so we get y equals, we get a -5. Okay, so that's what y equals. Now, if that's what y equals, we're more than halfway there because this takes so much work to get this first part of the solution. Watch what happens now. I'm just going to take this and we're going to plug it back into any one of these original equations. In fact, if you want to plug it in here, totally fine. If you want to plug it in here, totally fine. But notice that we've already got this equation that's solved for x, and x is the one that's missing. We already have y. If we put this right in here, we'd have our answer. So this is going to be x equals negative, whatever y is. So that's going to be a minus 5 and then minus 7. So let's take a look at what we get here. This is going to be x equals negative times negative is positive. 5 minus 7 is negative 2. So we get an answer of negative 2 for x. So I'm going to go ahead and circle that right there, and then all we have to do is make sure everybody knows we know exactly what we're doing when we solve a system of equations. We're going to write this down as a set of ordered pairs. So we're going to write down negative 2 comma negative 5 and circle that answer, and we are finished. So the substitution problems that we're going to do don't get any more difficult than that, and this idea is very, very valuable. The idea that we can substitute a value for something else. They ask for $1, we give it 4/4. Extremely valuable tool in algebra. We use this all the time, and if we plug things in parentheses, we're much less likely to make mistakes. Okay, let's take a look at this next one. It's got an asterisk, so let's see what happens on here. You'll notice that, none of these variables look like they're very good to work with. So let's see. Gosh, if I'd have to go through and divide everything by 5 on this one, so that's going to make a bit of a mess. I'd have to divide by 8 if I wanted to get that y by itself, so that's also going to make fractions, at least with this one. I could divide everything here by 4. 4 goes into 24 evenly, but I'd make a fraction out of this if I divided by 2 by 4. So let's isolate this one right here. So we're going to take equation number 1 and equation number 2. I'm going to take equation number 1 and I'm going to do this with it. I'm going to add 4y to both sides. So here's what we get. We get 2x equals, this would be 4y minus 24. We're going to divide everything by 2. And notice what happens when we divide by 2. Kind of getting back to those equation solving skills that we used when we were putting things in slope-intercept form. Notice that that cancels. We get a 2y, and notice that that cancels. We get a negative 12. So that is a copy of number 1. That's a copy of problem number 1, or equation number 1. It's just isolated the x. So now we've got something that we can plug into one of the other ones. So I'm going to change colors again on this one. Wherever there's an x, we can put 2y minus 12 in its place. So I'm going to do that right here. So this is what we're going to write down. This is going to be 5, and then in place of the x, we're going to put 2y minus 12, and then plus 8y equals negative 24. So notice it's the exact same equation that we had up above. There's the 5, there's the plus 8y, there's the equal negative 24. But right here where there's an x, I put in 2y minus 12. So let's go ahead and solve this and see what happens. So we're going to be careful distributing through. We end up with 10y here. 5 times negative 12 would be negative 60. And then we've got, let's see, plus 8y, and then over here we've got the negative 24. So let's see what we get here. This would be 18y, and then subtract 60 equals negative 24. We're going to add 60 to both sides, and we get this 18y on this side, and this would be 36 over here. If you want to double check me, negative 24 plus 60 is positive 36. Luckily, this goes in evenly, so we end up with a fairly nice answer. We end up with y equals 2. So I'm going to put a dotted circle around that. So we know what one of the variables equals. Now we just need to find out what the other one is. So we've got y, we need to figure out what x is. Now remember, you can take this and you can plug it into any one of those original equations, or if you consider this, we have a copy that's a true equation made from number 1. It looks different than number 1, but it's still a true equation. So watch what happens if I were to take this and plug it in right there. Remember, we know wherever there's a y, we can put a 2. So let's put a 2 right there. So this becomes x equals, let me do it down here. We're going to do x equals 2 times whatever y is. I'm going to save a place for that, minus 12. So this is going to be 2 times 2, which is 4, minus 12. So we end up with x equals negative 8. So I'm going to put a dotted circle around that right there, and this is the solution. Remember, we want to remind everybody, we know this is the point where the lines cross. The lines would cross at negative 8, comma 2. So I'm going to put a circle around that. We've got our answer there. And again, what makes this kind of difficult is notice that we're distributing that number through. We haven't had any like that before. So make sure that you're very careful. It's easy to make mistakes. Look at all that algebra that we had to do to get that answer. But again, getting that first part, it's way more than halfway. We've only got one of the two answers at this point, but then plugging that back in, it's very easy to get that second one. Okay. Let's take a look at some from the assignment. This is problem number 1. And on problem number 1, if we had to pick a variable to get by itself, I would say that this one is the easiest. So we've got equation number 1 and equation number 2. I'm going to take this one and I'm going to subtract 4y from both sides. So we're going to get x equals, this would be negative 4y plus 17. We're now going to use this and we're going to plug it into the other equation. Remember, if this is a copy of equation number 2, we don't want to plug it back into equation number 2. We want to plug it into the other equation. So here's what we're going to do. Wherever there's an x, we're going to put negative 4y plus 17. So there's a negative. We're going to put what x is equal to. It's negative 4y plus 17. And then it says minus 4y equals negative 17. So let's take a look at what we've got here. Again, careful distributing through. This would be 4y minus 17 minus 4y equals negative 17. And let's take a look. These are like terms, but 4y minus 4y is 0. So remember, the variable goes away here, and we've got negative 17 equals negative 17. So stop and think back. What did we get if the variables went away and what was left was a true equation? These two numbers do equal each other. What that means is there are infinitely many solutions. So if we were to graph these lines would be right on top of each other. And you can kind of see that from equation number 1 to equation number 2. You'll notice that all that happened here is each one of the signs on those changed from negative to being positive on the second one. Okay, let's take a look at the next one here. Notice this one's kind of cool. This one already has one of the variables for us. So I'm going to put a dotted circle around that right there. And we just substituted into the other one. So wherever there's a y, we're going to put a negative 3. If they ask for $1, we're going to give it 4/4. So this is going to be negative 4x plus 7. Figure out what y is. We're going to have a place for that. That's negative 3, and that equals 11. So this is negative 4x. This would be minus 21 equals 11. We're going to move that to the other side, so that would be add 21. So negative 4x equals, this would be 32. Divide by negative 4, and we get x equals negative 8. So I'm going to put a dotted circle around that right there. They already gave us one of the answers. It took a little bit of work, but not much to get the other one. So we end up with this, negative 8 comma negative 3. So we're going to circle that. We're done with the notes. Let's take a look at number 9 from the assignment. So I've got assignment 6.5b up here, solving systems of equations by substitution. Let's take a look at number 9. Number 9 says the sum of the first number and the second number is 12. The difference between the first number and the second number is 4. What are the two numbers? Now you'll remember that we encountered some of this earlier. Let's see if we can solve this. We're going to need some variables, so I'm going to use x and y. I'm going to say x is going to be the first number and y is going to be the second number. And it says the sum of the first and second is 12. So that means we're going to add them together. So x plus y is equal to 12. And it says the difference between the first and second number is 4. So that would be, I'm going to take the first one and I'm going to subtract the second one, and we end up with 4. Now that's the system of equations. Now you just need to go through and solve that. I'm hoping that this is something that you're pretty good at by now as far as translating a relatively simple in-context or story problem with systems of equations. But once we get to this point, you should be able to solve this pretty easily. And again, the technique that you'd probably want to use here, I suppose you could graph it if you wanted to. That's a bit of a pain. So solve this by substitution. I would say of these 4 variables right here, it honestly doesn't matter. I probably wouldn't pick this one right here. You could do either one of these x's or that y. All right, good luck with the assignment.